Welcome to the session on sequences and series, modelling with series. The objectives for this session are to model real-life situations with sequences and series. A real-life situation can be modelled with a series. So, for example, suppose a person's salary increases by 7.5% each year from £15,000 in year 1. Then we have that U1, the salary in year 1, is £15,000. The salary in year 2 is 1.075 multiplied by the salary in year 1. The salary in year 3 is 1.075 multiplied by the salary in year 2. And similarly, the salary in year 4 is 1.075 multiplied by the salary in year 3. So the salaries each year are A, where A is equal to £15,000, then 1.075 times A, then 1.075 squared times A, then 1.075 cubed times A, and so on. Notice that this is a geometric sequence. The amount earned over n years is equal to the sum of the first n values. So sum from r equals 1 to n of a times 1.075 to the power r minus 1. And as you can see, this is a geometric series. So annual salaries in this example form a geometric sequence, and the total salary over n years is modelled by a geometric series. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's take a look at part A first. We have a virus which spreads so that the number of people infected increases daily. To begin with, 50 people are diagnosed with the virus. A scientist predicts that 20 people will be infected every day until a breakthrough is achieved. Calculate the number of infected people in the first 15 days. Now clearly, this is an arithmetic sequence because we start with 50 who have been diagnosed with the virus, and then we add 20 every day. So we're adding on the same amount every day. So the nth term, recall, of an arithmetic sequence is u subscript n equals a, which is the first term, plus n minus 1 times d, where d is the common difference. An arithmetic series is the sum of the terms of an arithmetic sequence, and the sum of the arithmetic series has been found to be s subscript n equals n over 2 times 2a plus n minus 1 times d. So let's now solve the example. So on day 1, there are 50 people who are infected with the virus or diagnosed with the virus. On day 2, this has increased. There are 20 more people who have been infected or who will be infected. So we have 70 people altogether. On day 3, we have 20 more people. So altogether we have 90 people. Notice that the difference is constant. So of course this is an arithmetic sequence. And therefore A, the first term, is equal to 50. And D, the common difference, is 70 minus 50, which is 20, or the 20 can be taken directly from the question. And N, the number of days for which we are required to do our calculation over, is equal to 15. So if we want to find the total number of infected people on day 15 or in the first 15 days, we add up all the first 15 terms. So substituting in the formula, we plug in 15 or n equals 15 as shown, and a equals 50 as shown here, and d equals 20 as shown here. And calculating this gives us that S subscript 15 is equal to 2,850. And now for part B. We are required to state one reason why this might not be a suitable model. So let's solve this. Notice that the scientist has been predicting that 20 people will be infected every day until a breakthrough is achieved. Now 20 people is a very precise number. This is likely in real life to fluctuate, so it could be 19 or 21. It might vary, even if this is a very accurate model. So it is unlikely that the virus will spread by exactly the same amount every day. Now let's take a look at part C. Another scientist claims that the virus is likely to spread by 4%. Using this model, calculate the number of infected people in the first 15 days. You may have spotted that a geometric sequence will be at play here. Let's remind ourselves of what a geometric sequence and series is. The nth term of a geometric sequence is a times r to the power n minus 1, where a is the first term and r is the common ratio. A geometric series is the sum of the terms of a geometric sequence. Its sum is s subscript n equals a times r to the power n minus 1 all over r minus 1, where r does not equal 1. So let's solve our example. The value a is equal to 50 because this is the number of people who are diagnosed with the virus on the first day. And the value r, which is the common ratio, is 1.04. And the value n is equal to 15. We now plug in these values into the formula for Sn. So a equals 50 goes here, r equals 1.04 goes here, and n equals 15 goes here. And we find that S subscript 15 is equal to 1001 to the nearest whole number. Therefore, the number of people infected in the first 15 days is 1001. This brings us to the end of this session. If you have understood its contents, you should be able to model real-life situations with sequences and series. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.